everything together. This is a generic sphere, okay, so its radius is A. It's centered at the origin, but its radius is A. It doesn't have a specific radius. So it's given in rectangular form. So, just make sure people understand that, like, if you're given X, Y, and Z in an equation like that, that's rectangular form. If I wrote the equation of the sphere in cylindrical form, then it would look like A cosine theta squared plus A sine theta squared plus Z squared. Remember, in cylindrical, Z is itself. So then we get A squared cosine squared theta plus sine squared theta. I factored out the A squared. Remember, this is the Pythagorean identity. It equals 1. Why are we getting Z equals 0? We should be getting Z equals 0. Our radius is A, and so that would be R.
Oh, I see. You pulled one A out of the, oh, no, the whole thing was squared, yeah.
You know what, this actually has to stay R because the intersection with the XY plane is going to make a circle with radius A. But if you move up from that diameter, like, do you see the little pink line drawn here? The radius of that relative to the XY plane is smaller than A. So this has to stay the variable R. So, like, as I move towards the top, because remember, R is a measurement out from the origin in the XY plane, and then you get the rest of the point by then putting whatever Z is. So if Z's not 0, the points on here, the R is smaller than the radius of the sphere, so it has to stay the variable R. So we get that in cylindrical. And you could manipulate, like you could put Z squared by itself if you wanted to. You could put any of these. I'm just going to leave it like that, but that's a sphere and it's cylindrical. In spherical, it's just going to be rho equals A. That's what the equation ends up being in spherical. So if you wrote in spherical coordinates, it's just rho, which is one of our main variables in spherical coordinates, equals what the radius of the sphere is. So again, spheres centered at the origin are most simply stated in spherical coordinates.
So A is not the radius?
A is the radius.
And R represents the radius also?
Not of the sphere.
The radius at that height.
The radius, here,
At a point?
well, hang on just a second.
Oh, then the radius of the cross section.
A cross-section parallel to the XY plane. Because you can make cross-sections in other directions. R is the distance from the origin, but relative to the XY plane. It's not the, whereas rho, which is the radius of the sphere, is measured from the origin, but out, straight out in space. Whereas R is basically, you start off pointing down the x-axis. You then rotate theta. You then move out finally get to your point by then going up or down whatever Z you're supposed to go up or down. So this R is a radius relative to the XY plane, it's not the radius of the sphere. Because then the radius of the sphere, it is the radius out from the origin to a point on the surface. So there is one slice where R equals A for that sphere that I'll put the sphere back up. But if I slice that sphere through the XY plane, then R and A will be equal. But for any other, if I'm not on the XY plane and I'm on the sphere at any other spot, then R is gonna be smaller than A.
Okay, A represents,
The radius of the whole sphere.
right, okay,
I have a question on
Uh-huh.
that. So